Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to our webinar entitled Understanding Cyber Threats in the Automotive and Smart Mobility Ecosystem. My name is Andy Blanchard, and I lead our Emerging Issues team here at Verisk. We welcome you and are really excited to get our presentation going, but first, please allow me to review our policy statement. The policy of Verisk Analytics and subsidiary companies is to comply in all respects with federal and state antitrust laws. With this in mind, we want to mention that during all seminars held under our auspices, this policy prohibits discussion of certain topics because we want to avoid even the appearance of an antitrust violation. We go beyond the letter of the law, and we will not discuss any matter that violates the spirit of the antitrust laws or could be perceived as doing so. A copy of our policy statement on discussion at meetings can be found at verisk.com/statement. And with that, we have with us on the call a Verisk attorney, Carrie Ayala. Carrie, would you like to introduce yourself and provide some guidance?
Of course, thanks, Andy. Hi, as Andy mentioned, my name is Carrie Ayala. I'm an attorney in the law department here at Verisk. I know many of you are likely familiar with our policy governing discussions at meetings and webinars such as this one, particularly where there are many entities on the call. I'd just like to remind everyone participating that there should be no discussion of loss costs or rates or of corporate policies or intentions of any company in the industry. Further, the discussions that take place here are confidential. Should we get off track, I'll chime in, but I hope to stay quiet for the meeting. So with that, I'll send it back to you, Andy.
Thanks, Carrie. We'll certainly do our best to keep those guidelines in mind. It's great to have you on the call. In a moment, I'm going to be introducing our speaker. You see his face there on the screen, and I'm going to be asking him questions. And believe me, I've got a lot of questions. I should mention that besides leading our emerging issues efforts at Verisk, I'm also responsible for our commercial auto product development. So, you know, if there's anything auto-related and auto risk, I'm going to be there. So I'm really excited about this. But it's not all about me. You, the audience, will also have a chance to pose questions using the chat function in GoToWebinar. So please do that. And we are allotting time at the end for Q&A. And we'll do our best to get to as many questions as possible. And one last quick note, we do plan to share our slides that you'll be seeing today. And barring any technical issues, video recording as well. So keep an eye out for those. And with that, I would like to give a very warm welcome to Giuseppe Serio. Giuseppe is a VP of Market Development at Upstream, and you're going to very soon be learning more about Upstream's role in smart mobility and auto security. So with that, Giuseppe, great to have you.
Andy, thanks for the introduction, and I'm happy to be with you.
Wonderful. So let's get into it. Giuseppe, why don't we start with you maybe giving a brief introduction about Upstream to the audience, and then maybe we can get into what you folks do to help protect connected vehicles.
Sure. So Upstream is a company that was established 2017 out of Israel. That's where the headquarters is. We have presence around the world. Essentially, where the auto industry is, there is also offices of Upstream, the big three regions in the US, and Europe, and Asia. You see on the left-hand side of the slide some prominent logos. So those companies have early on started to invest in Upstream. And as of today, Upstream is protecting more than 12 million vehicles on the road. What Upstream does is we are a cybersecurity and data management company, purpose-built for the auto industry. And we have essentially three major offerings. One is a monitoring platform, which would monitor vehicles as they operate. Secondly, we have a practice which focuses on threat intelligence, again, purpose-built for the automotive ecosystem. And finally, we support the operation of vehicle security operation centers. This is the governance piece, if you will, where a security analyst will monitor those vehicles as they operate, and if there's any anomaly, would take the appropriate actions and inform whatever the playbooks behind that are.
Oh, thank you for that background. So I guess a good place to start is, just to ask, I mean, vehicles have been on the road, cars and trucks, for over 100 years. Why now do we need to start worrying about them being so vulnerable?
Yeah, that's a very interesting question. Cars have been around for a very long time, as you said, and for the most part, the vehicle was a piece of engineering, a masterpiece of engineering, essentially metal. Then in the 80s, you would have electronics be built into the vehicles, and already by that time, you could manipulate what was developed in terms of the electric signals that would come with those embedded systems. For instance, you would do chip tuning or even automotive reductions. So it's not really that cybersecurity is a big thing, or is a big thing today, I should say. It's that because of the connectivity to the internet, that notion of exposing vehicles now to the internet actually means that this is a different game. And we know that the internet can be a very unsafe place. And you see on the slide that over time, actually what we're dealing with is no longer a vehicle. What we're dealing with is a mobile computing platform that is on wheels. So essentially from a hardware-based device, getting now a software-based device, which obviously with software introduces also a lot of vulnerabilities that can be exploited. And you see on the chart as well that as we move into electrification or autonomous driving, charging stations, the way that we communicate and enable features for the vehicle to the vehicle, you see it here depicted as APIs. That's something that introduce totally new attack vectors that were not there a few years back. And the industry is moving really fast, unlocking the value of the smart mobility ecosystem, trying to monetize all those new services. And that is the perfect storm for attackers to try to leverage vulnerabilities out there for various reasons. And another important topic is, so today you may have heard about this concept of the software-defined vehicle, meaning that the vehicle is essentially becoming a part of the cloud environment in itself. So features can be updated really quickly. In the past, it took 4 or 5 years to develop a vehicle, and that set of capability would run then until the end of the life. Now, in the future, we will see that features will change rather quickly. So the behavior of a vehicle can dramatically change by the updates and new features that will be introduced.
I guess that makes sense. You said it was a computer on wheels, so just the way you update your computer, you can update vehicles and change their behaviors. So I guess the next thing I'm thinking is, so are we're seeing all these vulnerabilities. Are vehicles protectable? And if so, to what degree can we protect them?
Well, as anything in the IT or software business, and in the IT world, we have dealt with cybersecurity now for 20, 30 years. What is important is the idea of, as vehicles operate in the wild, and in the wild meaning they're connected to internet, and that is an exposure in itself, but also it's operating and it's exposed to people having physical access, which is different to the parameter in the corporate world. Because of that exposure, what's really matters is to be resilient on one hand, and also to understand how attacks are carried out. What I would suggest is an interesting concept is to understand and look it in terms of anomalies, because a cybersecurity event per se is not classified as something that you can confine in its terms, meaning there's no 100% use cases that you can say this is 100% cyber, because some of the use cases or some of the features or some of the activities that are possible today on modern vehicle are because we want to create a better customer experience. So, for instance, being able to open vehicles with a smartphone, or even starting the engine, that in itself is not really a cyber use case. However, if that is carried out and done remotely, and it's thousands of miles away where that signal originates, then that anomaly can become clearly something that is suspicious. So I would rather talk in terms of what is it that we need to look for in order to spot those anomalies that could itself then manifest into something that is a real cyber attack. And are vehicles protectable? That was the original question.
Yep.
If you look at this slide, we have to understand that just looking at the vehicle is not enough, because with the example I gave by the remote opening of vehicle or starting the engine, it's really the entire mobility space that we need to look for, and that is a very, very complex environment. So is it protectable? I would say to a certain degree we need to do in the industry whatever it takes to raise the bar, but we have learned that cybersecurity is nothing that has a definite end or a definite solution. It's something that is ongoing, and what seems protected today, maybe tomorrow isn't, because there's a new way to attack or a new vulnerability that is discovered. So again, I think what matters more is to look in terms of resiliency and how can we protect or put in sort of a safe mode a vehicle as we see anomalies happening.
Yeah, I guess that makes sense. The environment's dynamic, and we have to keep changing to and adapting to new threats. Speaking of threats, who are the threat actors, and what is their motivation?
Now, in terms of motivations, as you can see from the next slide, what we clearly see is that as of today, the people who are trying to tamper with the smart mobility ecosystem are, quote unquote, the bad guys, so the black hat, so the people that have some interest. And the interest can be from monetary gains or even threat actors on a nation level, sabotage, etc. Versus on the other hand, you see it's roughly 40% where you have the white hat, which are the good guys, so people who do research and also publish those vulnerabilities for various reasons, for educational reasons. So the ones who actually help advance the cause and advance the and improve the cybersecurity posture of the industry. Last year, this flipped. So as of last year, we see, and this research that you see is conducted by Upstream, and you can find it in the yearly report that we issue. It's clearly telling us that now we need to really look at what's happening, because now the bad guys are taking over. And the other number that you see here on the slide, 253% increase, is again telling us that just in the last year alone, that was the increase of new attacks that we have seen compared to the previous year. So the attacks are coming. It's coming from people who have some form of interest to do what they do. For the most part, it is for monetary reason, and it's something that we will increasingly see, because, as I mentioned before, the industry is moving in monetizing data into enhancing the customer experience and the customer journey, and that will in itself unlock new features that are prone to be tampered with because there is monetary interest, or there is money behind it that attackers could tap into. So we need to really look how we deal in the near future with these types of increasing attacks. And just to give you an idea about the magnitude, so every day, about 500,000 of new variants of malware are discovered, meaning that the notion of you cannot really fight it, but you need to be aware and in a certain way try to stay resilient is really what is key.
Yeah, it certainly sounds like increased vigilance is going to be required, because the threat is only appearing to be growing all the time. So Giuseppe, I did want to ask, what are the common vectors that these auto hackers, these bad guys, exploit? And while you're at it, what are some potential risks at EV, electric vehicle, at charging stations?
Right. So I think the concept of EV and charging station, that's something that is newly introduced because now EVs are becoming pervasive around the world, and so are charging stations. That introduces in itself also new attack vectors. So I've put here the next slide. You can see that the attack vectors that we see, and this is again based on research that Upstream conducts, as of today, server attacks and also attacks to key fobs, so how to steal cars, is very predominant in the industry. That's what we see overall. Interestingly, and maybe the text here is really tiny, but to give you an idea, the pillars on the right-hand side, they all reflect in a certain way the attack vectors of the vehicle itself. And as I mentioned before, what really matters and what is really dramatically increasing is the fourth pillar. On the left-hand side, you see the number 7.3%. That is the mobile app. So the new features, the interaction between our companion app, our mobile apps with the ecosystem and with the vehicle is something that has tripled in the last year alone. And that number is already higher than the in-vehicle attacks. Why? We have put, as an industry, a lot of effort. We see a lot of effort to harden and to make it more difficult to attack vehicles or to even get into the vehicle from a cybersecurity perspective. But now, with electric charging station, or even with updating capabilities over the air, we are literally introducing new attack vectors which have a different purpose to serve. However, they could be exploited as a channel to attack the vehicle and also the newly introduced attack vectors, such as a charging station. So we will see a lot of new types of attacks because of the new capabilities that are opened up to the ecosystem as we continue to evolve services, offerings, but also capabilities on the product itself.
Yeah, so it sounds like as these capabilities and as these services expand, so do the threats. It just sort of seems to go hand in hand in some ways. Giuseppe, maybe you could speak a little bit to us about how the frequency of hacking attempts, or should I say successful exploits, since I mean, I'm pretty sure that not all attempts actually work, but how is that frequency changing over time?
Yeah, I would say that as I have shown on previous slides, the bad guys have entered the scenes. Attacks are becoming more and more prominent. They're moving from traditional attacks on the vehicle itself to the services. Our research suggests that there is a 3.5x increase over the last 10 years. So it's an exponential growth of new attacks, vulnerabilities that we have seen. And I guess there's a lot of attempts which we even don't notice, because one of the important things and capability to have is to being able to monitor if an attempt or if something has been launched. Why? Because it's important to understand that an attack in itself is not a one-off thing that you start and execute the very same moment. So it takes time for an attacker to find a vulnerability, enter a system, move around, and continue to find the sweet spot or the vulnerability that can be exploited, and then actually execute that. So it can take a long time between finding a vulnerability and then actually executing. There could be also strategic consideration for, there is the ability to execute on an attack, but maybe there is a timing concern by the attacker or a specific event that needs to happen in order for that to be triggered. So we need to move away from that notion that attack and execution of the attack are something that happen at the same time. And in terms of the frequency itself, as I mentioned, we will see the amount of attacks that we are very familiar with in the IT world, where corporations sometimes are attacked thousands, hundreds of thousands of times a day. On the corporate level, I believe we will see that type of phenomena also in the smart mobility context.
So lots of probing and planning and figuring out how to make these attacks successful. That's interesting. And that's I think I heard you say 3.5 times increase in 10 years. So that's pretty sobering as well. Giuseppe, what are some general categories of risk presented by auto malware and ransomware? And, for example, the risk of an auto being bricked unless a ransom is being paid, or the risk of losing control of a vehicle. I know that's the big fear for a lot of people, and a hacker causing an accident, right? Or even beyond that, there's network infiltration, loss of personal and business and private data, and even infection of a connected device. You connect a mobile phone, and maybe that can get connected from the virus that's in the vehicle. So I know I'm talking a lot, but could you maybe take it from here and walk us through some of these categories?
Yeah, sure. Maybe first let me answer it this way. You mentioned ransomware, loss of control, or accident. Personally, I believe that for the most part, attacks have a monetary component to it. So people want to make money. So attackers are there for the monetary gain. It's not so much of attacking a person to harm the person itself. However, it can lead into consequences if we think in terms of an autonomous vehicle, and maybe a driver is focusing on its ADAS systems to do a semi-autonomous driving, and one of the sensors, because of a cyber attack, is not carrying out the function. So then this can lead into something that will harm people, or will have consequences to loss of property. But for the most part, I truly believe it's about the monetary gain here. And again, as you can see on this chart, the prominent part as of today, so connected vehicle, our research suggests that it's quite easy these days to steal cars. So that's the most prominent thing beside data breach. And taking control of car systems is also something that we see. But more importantly, again, in that notion of monetary gain, fraud or manipulating components, again, like automated reduction, or doing things that would keep warranties up and running, is something that we see happening, and we see the increase of that activities being carried out. And you see again here on the slide, 40% of the incidents that we reported in 2021 have something to do with privacy or data breaches. So data is really important, and something that again will stay over time. But on the other hand, the attacks on the vehicle for multiple reasons, like you mentioned, ransomware, that's something that we will see for sure in the years to come to increase.
Well, it certainly seems like there are a lot of categories here to be concerned about. And that was interesting also, just the idea that, you know, if there are accidents, it could be just a symptom of a more primary motivation to extract money in some way, you know, that they're motivated by money or ransom. Giuseppe, you're clearly the expert here, but I did want to sort of call out something before I tee up my next question. So just, you know, for people hearing my voice, if your car is less than more or less 30 years old, and I'm guessing it is less than 30 years old, you may not realize that there's essentially a communication network going on underneath the hood of your car. It's called a CAN. It stands for Controller Area Network. And with that, Giuseppe, I have to ask you, and you touched on this a little before, but how does a vehicle's internet connected system potentially interface with this CAN system that's in a vehicle? And I think you probably know where I'm going here. So what might be some of the safety concerns when your car is basically on the internet?
Right. Yeah, so as you can see here on this next slide, it's a very simplistic view of an in-vehicle architecture. So you have essentially today, and it's right, so you mentioned vehicle beginning of the 80s, as I mentioned earlier, they started to use CAN, which is a onboard protocol, which perfectly works in a context where you just need to operate a vehicle. So it was never built with cybersecurity in mind. Now, on the in-vehicle architecture, you have some key components. So on one hand, you see here something depicted as a TCU, which is the telematic control unit. That's the unit that establishes the connection between the vehicle and the OEM cloud, so the car maker's cloud typically. In between, there is a cellular network, so there's a lot of companies which around the world offer the mobility services, the data, the mobile data to connect. So in that TCU, you would have a SIM card that establishes the connectivity, and then you can either send or receive data. these days, for the most part, the infotainment system, which is where you have all the navigation and Bluetooth features, etc., mostly they come together. But there are also architecture where this is separated. On top of it, you have something which is called a central gateway and other ECUs. So in a modern car, and again, as I mentioned, this is very simplistic. In a sophisticated modern car, you can have up to 150, 170 single ECUs. And think of an ECU, if you're not familiar with the auto industry, as a mini computer that can execute and is responsible for various features. So, for instance, it's for the windshield or opening the trunk or whatever. So, purpose-built mini computers who have a task and they can execute, and the central gateway is sort of a hub where you distribute the various messages. You see here CAN, you see Ethernet. There are many other protocols that are used these days on the car. I would say most prominently, we're adapting a lot from the IT world with Ethernet and IP connectivity. So that is something that a car is built upon these days. The architecture will dramatically change or is already changing for various reasons. One, the complexity of the vehicle is no longer something that is manageable for the OEMs, because, as I mentioned, those functionalities, they are purpose-built and they are provided by several players, so-called tier ones or tier twos, that would supply it, or based on the requirements of the car maker being provided to the car maker, who then is finally assembling them. And in terms of cybersecurity, for the most part, it's a black box. So from an OEM perspective, it's really hard to understand what type of software, what is running literally in those components, because the very same ECU is not only in one specific car model of one specific brand. It can be in many, many vehicles. And it's also important to understand that for the most part, we talk today in terms of passenger cars, because that's what's interesting on a large scale for people who are interested in the subject. But note that there are different segments, like commercial vehicles, like construction machines, etc., etc. And what is really important is that cybersecurity concerns for those various segments can be totally different, because they are not sold to end customers. Many times it's just fleet operators, or it's other companies, so it's a B2C model. It's a total different type of assets. Sometimes even components are different. And therefore, in a simplistic architecture, as I mentioned, an attacker would try to, if it's coming remotely, maybe the entry point could be the telematic unit or the ECU that is responsible for over-the-air updates. However, if you are in the proximity of the car, as I mentioned before, tampering and trying to find vulnerabilities on single ECUs, because it's literally possible to get their hands on those devices, is something that we need to take also into consideration. So one thing is the network in the car. The other thing is the interaction either remotely or in the proximity of those ECUs. And therefore, the CAN, as I mentioned, was never built for cybersecurity. It was a proprietary protocol that would perfectly function. The problem really started when it was connected to the internet, because what really is the difference between a single attack on the car and the exposure to the internet is that attacks can scale. So looking again from the perspective of a hacker, of an attacker, it's much more efficient because there is no need to be in the proximity of millions of cars versus doing it remotely and executing and exploiting a vulnerability once can affect millions of vehicles at once. And that's really interesting because effort, efficiency, time, also the bad guys are looking for economies of scale and therefore are really looking into exploiting large-scale attacks. That's really the key here.
That's interesting because I know amongst our auto team here at Verus, we kind of think about that too. And like, are they going to go and try to, you know, hack the Ferrari? And then we kind of come back to, well, you might get a lot in a ransom payment, you know, but how many of them are on the road? Maybe better to target a vehicle that's made in mass, you know. But you really kind of help draw a picture, and just keeping in mind the complexity that you described of these microcontrollers and these devices and ECUs and how they're exposed to the internet. I mean, this is a lot to take in. Like, how are the OEMs typically implementing cybersecurity in light of this?
And maybe to add one more thought on that. So again, if you look at the picture and you would want to compare it, let's say, to a computer, a notebook, the complexity in the in-vehicle architecture is really that those ECUs may come from different providers, meaning that the same vehicle model and make of that same year, although from the outside looks identical, maybe from a software perspective, a total different thing. And that's what makes it so super hard and is really different to the IT world, because if you assemble a computer, the parts and pieces that come with it, they are identical. It's just a replica of that computer n times. In the car world, because of diversification and because of many other reasons, the same vehicle parking next to each other may look the same, but they are totally different from a software perspective. Also because one has features that the other does not have, because the configuration per se was such that for one consumer, it was enough to have some features. For others, it's other features. So the complexity really comes with the ability or with what's equipped in the car, but also outside of the car that the vehicle can interact with. And that's really unique and important to point out and understand. Now, getting back to your question, how are OEMs typically implementing cybersecurity? As of this year, in particular, I would say European, Asian countries were obliged to enforce something that is a new regulation. It's 58 countries. It's the UNSCE WP29. So it's very technical if you're not part of that automotive world. It's R155, which mandates a cybersecurity management system, and R156, which mandates to establish a software management system. In order to understand during development, manufacturing, and as vehicle operate, and have the due diligence done for that three phases to really take care of cybersecurity. Now, spontaneous question would be, okay, well, what about US and all the other countries? Because I mentioned 58 countries, right? So that has raised the bar. That is becoming today, I would say, the de facto standard. Pretty much like in the past with GDPR in Europe, that was setting the bar really high of what the industry has to do and needs to do in order to address it. Keep in mind, security is something that adds cost because there's a requirement to protect something which without cybersecurity may be exposed. So in that sense, it's making a product more costly. Now, in terms of what the industry is doing, on one hand, the regulations are mandating not exactly on a prescriptive level what they have to do or what needs to be done, but that enough cybersecurity is part of the processes, part of the technology that goes into the vehicle, and take care that nothing bad happens. And to that end, the auto industry has embarked on that journey, and now, because of the different variation that a vehicle can represent, so as I mentioned, different segments. Think of a very luxury sports car or luxury sedan who has a lot of features versus a vehicle that is already out on the road and has a few features because it was built a few years back and it can be considered still a connected vehicle. So the amount, quote unquote, the amount of security may differ, but not because it's less worth to be protected, because of the functionality and features that need to be protected. In other words, cybersecurity for the auto industry is something that adds cost. So finally, it needs to be something that is affordable and it makes sense, because if there are no attacks on one hand, then that's something that can be looked in a different way. Meaning, if you focus on what is really, from a threat analysis perspective, a big risk, you want to address the big risks, and obviously address the ones which are less of importance. However, there will be always a trade-off. And why? Because, as I mentioned, the vehicle is becoming a software platform, and there's a constant update. So keeping up the cybersecurity with that constant updated version of effectively a new device or a modified device is something that's really hard. And at the end of the day, cybersecurity with the new regulation and very other cybersecurity initiatives around the world will become much better than it is or has been in the past, where this is was not even on the mind of the car makers. But again, not because of any negligence, but because it was not a thing, and now that is becoming much more important. There's obviously something that needs to be done about it.
Yeah, of course. So, one thing I've been reading about is that, vehicle service lives are they're longer than they've ever been. I think the average private passenger vehicle is on the road for over 12 years. New cars are really expensive right now. So all that kind of tells me is that cars are getting older, and we have these legacy fleets out there. So I'm kind of thinking or asking, how can security be implemented on these legacy fleets, or are we only really talking about new vehicles that we can do these things to make them more resilient?
Yeah, so putting security back into something that was not designed in from the very moment is really hard. So it's really hard to include or incorporate security afterwards. Predominantly, we are talking about the newer vehicles where this can be designed in, and this is something that from a vehicle perspective will also be something that you can monitor to understand the behavior. And in order to do that, you need data that will give you the insight as how vehicle operate. For the older vehicle, again, they may not come with so many features, but they are at risk. There are some aftermarket tools that could be leveraged and implemented. But again, from a life cycle perspective, the real challenge here for the industry is how do you maintain security over time? So from the day it hits the road, or I would say even before that, as vehicles are planned until they hit the road, that's already taking years. So the moment you have a new vehicle on the street, it comes equipped with eventually outdated cybersecurity mechanisms. And now think of it, maintaining it for, on average, a passenger car is said to be operated 12 years. But how about construction machines or tractors who are out there for 15, 20, 40 years? That's really, really hard, because in the IT world, nobody has tried to ensure security over such long period. And I would say we will come to a point where it's really difficult to update security mechanism, even though there will be the ability to patch. And again, that's something that is really hard to do with older vehicles. You would need to recall them in a service shop and flash it. So it's a logistic. From a logistics perspective, it's really hard to do it. Now, on the new ones, it may be easier, but again, the very long time of operation is something that at some point in time, either the software will become vulnerable, and we have a lot of examples like encryption over time degrades. So the software degrades very much so, and at some point, even the hardware cannot be updated with the new security features. So we need to think about in the industry really at some point what are features that eventually needs to be blocked, or a vehicle considered no longer secure needs to be disposed. So that's the concern that we need to have. Obviously, that has a plethora of implications, which may be good for another webinar.
Thanks, Giuseppe. And I just wanted to call out that we are receiving the questions. Thank you to the audience for adding to the chat. We're going to have to get to the Q&A pretty quickly, Giuseppe. So let me maybe just queue up one more question for you, and then you can just walk us through I think we have a couple more slides left. I guess without really, I don't want you to call out a make or model, but how might different classes of vehicles, like connected vehicles and autonomous vehicles, electric vehicles, how do they exhibit different vulnerabilities?
Yeah, I think, as I mentioned before, it's really we need to look beyond the vehicle. So it really doesn't matter if it's a pure connected vehicle or an automated. We need to look at an ecosystem here. So anything that is in the transportation business that is deploying software at some point has inherent vulnerabilities, and chips that, for instance, are embedded in refrigerators may also be in a vehicle, meaning that a vulnerability that affects a different industry may affect the transportation or the vehicle automotive industry as well. So we need to look more in terms of what are potential threats and vulnerabilities that need to be understood, managed, versus looking at specific models, because that is something that will add no value from my perspective.
Okay, so Giuseppe, if just again to allow time for questions, can I ask you to just go through your last few slides briefly, and then we can get to the Q&A?
Sure. Yeah. So on this slide, you see a quote, and I think there was a big attack 2022. So this year in Moscow, where it was a large-scale attack, as I alluded to previously. And in 2017, that was seen as something that would be really scary. And it's again on that notion to say, because as of today, we believe that we have everything in place, that something is safeguarded, tomorrow may not be the case. And that's why resiliency is really important here, and have the ability to understand, to collect data, to look at the context where vehicles operate, to be able to spot signs of anomalies, which then could be addressed and could eventually avoid large-scale attacks, such as the one that we have seen in Moscow, where it was possible to call hundreds, if not thousands, of taxis into the same location, causing a congestion. Now, that may be a quote-unquote a fun attack, because nobody was literally hurt. However, if there is a congestion and there is a fire somewhere, and the fire brigade needs to get there, and something like this happens, again, there is collateral damages that could happen, which are really important. And I think it's really important to understand how things that today are perceived secure, tomorrow maybe not.
Right, thank you, Giuseppe. I think, did you want to speak to this slide, or?
Yeah, yes, maybe
Okay.
maybe the last thought on the slides.
Okay,
I think I've touched on that now several times. The next big wave will be the features and the services that we want to unlock in terms of enabling capabilities to monetize. APIs is a way to communicate with the ecosystem to unlock those type of services, and that is going to be the next big wave, because this is a window that is opened to do something with the car. So it's really important that we understand the interactions of all those services with the ecosystem, the charging station, the vehicles, the web applications, other third-party tools, or the companion apps that are part of this ecosystem, and they heavily rely on APIs, which is the connections to those services, to make them as secure as possible. And that is what I think my last slide. Going back to you, Andrew.
Wonderful, thank you, Giuseppe. If it's okay, I can pose a couple of questions to you, and I guess the first one I'll answer myself. Somebody had asked if the slides are going to be available to the attendees. So the answer is, if you are an ISO customer, a Verus customer, we do publish the slides in a circular. And you should know what a circular is if you're our customer. Hopefully you do. If you are not, and you would like to see a copy of the recording, we do intend to publish that, and that should be publicly available. I don't have the exact date yet, but that will be up on our site. So we do want to get that out there so people can see it. Next thing I will direct to you, Giuseppe, if that's okay. Our car, or I guess I should say it this way: as car manufacturers use older versions of chips, older chips at lower cost, does this impact the vulnerability of vehicles in your view?
Definitely, it can come with vulnerabilities that may be exploited. So older chips can be an issue for sure.
Yeah, I can see that, and I know we've been reading about that with supply chain issues and chips, and
yeah, and it's not only the chip in itself. I mean, with the geopolitical situation today, sometimes it's also counterfeit products. So you may believe that this is a legitimate chip, but eventually it's not. So that is also something that is important to be aware of.
That makes perfect sense. Thank you. We are getting some questions here we really can't get into in terms of what we're doing with specific ISO products and loss costs. What I can say is we have been very mindful of this exposure for a while. We have been researching them. We have some solutions in the marketplace. If you are customers, you can go into ISOnet, you can call me, there's my contact info on the screen, and I'd be happy to discuss more about what we have done and what we're looking to do in the future with regard to this growing threat that Giuseppe has really detailed for us today. All right, so we're going to close things out here, but before I do, I'd really like to thank our audience for joining us. I do hope they learned a lot. I know I did. And most of all, I really want to thank Giuseppe Serio and the fantastic team at Upstream for really making this whole thing happen today. As mentioned, we intend to share the slides and the recording of today's event, so stay tuned for that. And until next time, stay safe, everyone. Have a great rest of your day. Thank you.